Hi guys, today I'll continue discussing my theory on the purpose of the Giza pyramids and other large pyramids in Egypt. In my last video, I laid out evidence on why I don't think the Great Pyramid was an ancient power plant. Currently, most studies are focused on the Great Pyramid of Giza, though I believe we shouldn't single just one pyramid out without comparing it with other similar ones. We need to consider and discuss all the large pyramids in Giza, Dashra, Abusir, and Saqqara as a group. There must be an intrinsic connection among these impressive structures. These everlasting constructions were not built for form only. They must have had a significant function, which led to their creation. The Great Pyramid of Giza is the only one that has connecting above and underground chambers and passageways, while other large-scale pyramids do not have the same internal structures as the Great Pyramid. They have minimal openings and remain almost entirely solid, sitting on top of underground chambers. Who would build such massive objects that one can't even use? Even for the Great Pyramid, if the goal was to create chambers and passageways, then it was completely unnecessary to pile up all these stone blocks. If the builders just skipped every 10 blocks or so, a lot of labor would have been saved, and the structural integrity wouldn't have been compromised. Then why would the ancient builders choose to employ so much labor and building material? Unless it was their intention to pack as much material as possible into one place. The way these pyramids were constructed indicates that they were designed to contain as many blocks as possible. This could be their function, which was to safely store enormous amounts of blocks. So what kinds of blocks need to be stored this way? In an earlier video, I pointed out that the large-scale shafts and underground chambers on the Giza Plateau might belong to an ancient underground mine. These shafts are very close to the pyramids. The Great Pyramid shared the same tool marks with the Osiris shaft. It's conceivable there was a fundamental connection between the Giza pyramids and the underground mining system. If these ancient shafts on the Giza Plateau were excavated for mining, then what possible role could the pyramids have played in this complex operation? Some have gotten my hints from the last video, my theory being the pyramids might be carefully constructed mine tailing and waste rock storage piles. What? I know. It might sound outrageous because the Giza pyramids are such pivotal symbols to us. Calling them mine waste dumps or slag heaps is just plain offensive. Even though emotionally it's hard for me to accept, but this tailing storage theory did derive from my research. I was never inclined from the start to conclude the way I did, but all my research points in that direction. Imagine if all humans suddenly disappeared today. Tens of thousands of years in the future, what would be recognizable to prove the existence of our civilization? Skyscrapers? No. Modern structures require regular maintenance and repair. Once the maintenance ends, the buildings would eventually collapse. However, earthly structures such as mines and rock-cut caves would last the longest. The megalithic sites that stir up so much interest among us are probably the bare bones of a previous advanced civilization. If the Egyptian pyramids were really intended as mine waste storage, it actually proves that this ancient civilization was so advanced that today's technology is far from reaching their level. Let me explain my reasons, and afterwards you can make a judgment call on whether my theory has merit. First, let's take a look at some typical mine sections. We can see the shafts, which are similar to the Giza shafts, the underground passageways to the ore, and on the ground we can see something in a pyramid shape. That's a pile of mine tailings or waste rock. Mining produces a lot of waste. When one catches a glimpse of any mining operation, in most cases, you'll likely only notice the mine waste because the majority of the actual operation is underground. When metal is mined, it typically is mixed with other rocks. Chemicals, such as cyanide, are usually used to separate metal from ore. Once the metal is removed from the rock, the excess rock becomes waste rock. Other than waste rock, the extracting process also produces mine tailings. Tailings are finely ground rocks and other mineral waste. Waste rock and tailings generally have little to no use and thus disposed of. Due to the way minerals are processed, tailings and waste rock can contain concentrations of chemicals. If not properly handled, hazardous and toxic material from mine waste, such as heavy metals, acidic water, and chemicals, can be released into the environment. Because mines are usually operated in great scales, massive areas of soil, land, groundwater, and aquifers could be potentially polluted, which would cause major public health problems. Sadly, the mining industries have historically used the simplest and cheapest methods to manage mine waste, which is to dump them directly into rivers and lakes or pile them up on ground or in pits. Wind and rainwater then spread the contaminants to local and downstream soil and water sources. This is a disastrous way to store mine waste. Since the mid-20th century, the mine industries were pressured to eliminate older ways of waste dumping and look for safer, environmentally friendly technologies. The most common method of managing tailings today is stockpiling tailings slurries in tailings ponds. Some of the largest tailings ponds are over several miles in diameter and hundreds of feet deep. Tailings ponds are not only ugly to look at, but dangerous. There have been several catastrophic large tailings pond failures. In addition to the loss of up to several hundred human lives, these major failures have contaminated and destroyed large areas of land and caused major ground and waterway pollution. So building tailings ponds is not an ideal way to store mine tailings. How can we permanently and safely store mine waste? In recent years, there is a new concept called dry stack tailings. In the dry stack method, filtered tailings are placed and compacted into a mound. Since there is neither a tailing pond nor dam, there can be no dam failure. Dry stack tailing storage has been found to greatly improve the structural stability of the material storage. Also, storing mine waste on the mine operation site is more cost-efficient and environmentally friendly because it saves transportation costs and limits the contamination footprint. The dry stacking and cemented tailing paste technologies can dispose tailings more effectively with a much less negative impact on the environment. This method can recover the maximum amount of recycled water and residual chemicals. So far, it's considered the most sustainable and efficient method of physical storage. Speaking of cemented tailings paste technologies, I need to bring up a fascinating and plausible theory from Joseph Davidovits, a French materials scientist known for the invention of geopolymer chemistry. Professor Davidovits proposed that the pyramid blocks are not carved stone, but were mostly cast with a form of limestone concrete. There are multiple scientific papers with various material analysis results supporting the man-made pyramid block theory. For example, in this 2006 paper, Microstructural Evidence of Reconstituted Limestone Blocks in the Great Pyramids of Egypt, the researchers stated the pyramid samples contained microconstituents with appreciable amounts of silicon in combination with elements such as calcium and magnesium in ratios that do not exist in any of the potential limestone sources. The sophistication and endurance of this ancient concrete technology is simply astounding. Another study used paleomagnetic investigation of the rock material of the great Egyptian pyramids, Khufu and Khafre. The paleo directions of 3 sampling locations exhibit the common north-south orientation, suggesting that they may have been produced in situ by a concrete technology. Finally, we conclude that even the concrete techniques was used. The pyramids were constructed from a mixture of natural and artificial limestone blocks. Here I want to point out that the mine waste at the Giza Plateau probably had both waste rock and silty tailings. If a cemented method was applied to this mine waste, then the end result will be a mixture of natural and artificial limestone because the waste rock will be like aggregates in today's concrete. Furthermore, not only are the pyramid core stones man-made, so are the casing stones. Scientists have analyzed the casing stone of the Bent Pyramid. The NMR results suggest that the casing stone consists of limestone grains from the Tura quarry, cemented with an amorphous calcium silicate gel formed by human intervention. Why would the ancients have used a different, higher quality, smooth material for the exterior casing stones of the pyramids? Please keep watching. By the way, the links to these papers are in the video description section if you want to check them out. Egyptian pyramid blocks tend to contain fossil shells and nummulite. Some were jumbled up together haphazardly and look artificially mixed. Some were intact. Certain researchers argue that this is evidence that the pyramid stone is natural rock. I think the intact fossils might also come from waste rock. It's possible that the ancient miners combined waste rock and tailings with binding paste like cement, which the end result was blocks with fossils. Now, the cemented tailing paste technology is a new concept. I haven't found any large-scale cemented tailing mounds in practice today. If it's a superior tailing storage method, how come there's no company utilizing it now? Large-scale waste rock and tailing storage is actually very complicated and requires in-depth calculation and simulation studies, because such storages are designed to permanently store potentially toxic materials. This is a great responsibility, and future failings of such structures can be disastrous with lasting consequences. Therefore, even though not glamorous, mine waste storage is critical and demands careful planning and design. Here are some conceptual models of dry stack tailings. These diagrams show crucial features that are comparable to the big pyramids of Egypt. I found 6 similarities between the dry tailing mounds and the pyramids. 1. Shape. A pyramid is the most structurally stable shape for projects involving large amounts of stone or masonry. Why did all the mine graphics show a pyramid-like shape? This is no coincidence. Pyramids have a consistently low center of gravity. The waste rock and dry stack tailings, like other sediments that occur in nature, would naturally build up in mounds because it's the most stable. The tailing mound design, in its best and most efficient form, would be in a pyramid shape, similar to the Giza pyramids. 2. Scale, size. The Great Pyramid was built with an estimated 2.3 million big stone blocks and weighs 6 million tons. The Khafre is slightly smaller, but it's solid, and so is the Menkaure. Therefore, the 3 Great Pyramids on the Giza Plateau together easily weigh over 12 million tons and contain over 4 million large blocks. That's 24 times the weight of the tallest tower in the world, Burj Khalifa. What kind of structure would need these astronomical amount of solid material? On the other hand, mining can produce overwhelmingly amounts of waste. Today, some large mining operations produce well over 100,000 tons of dry tailings per day, which means one of these mines can produce enough material to build the 3 Great Pyramids in 4 months. Let's assume for a minute that the Giza mining system was similar to a modern mine with an operation time frame of 20 to 30 years. It's reasonable to also assume that the mine would have generated enough waste material which would be comparable to the sizes of the Giza pyramids. Tailing mounds are built up in phases. As the mining goes on, new waste material will be treated, consolidated, and moved to an ever-growing pile. I think this could be the same method for how pyramid blocks were placed. 3. Solid feature. Most ancient pyramids in Egypt are predominantly solid with small fractions of interior openings. The Great Pyramid has the most elaborate interior system, but considering its overall mass, is still pretty much solid. From a construction point of view, it doesn't make sense to use so much building material to construct these enormous solid structures with so little usable space, unless the goal was to pack as much material as possible. If these pyramids were meant for storage of mining waste, then we can explain their solid features. By the way, the majority of the stones at the Great Pyramid are local limestone from the Giza Plateau. They are not uniform in size or shape and are only roughly dressed. I think this makes sense, since the blocks of cemented waste rock and tailings don't need to be perfect. 4. No foundation. Pyramids have no foundation and are built directly on the ground. The Giza pyramids are sitting on a limestone bedrock, and other pyramids in Dashur, Abusir, and Saqqara also have no foundations. The dry stack tailing mound have the same characteristics. Moreover, from the tailing mound designs, we can see buttresses at the bottom corners and the outside layer of the mound. Now, that's the 5th similarity. 5. The use of casing stones and corner buttresses. We know that the pyramids originally were all covered with fine quality casing stones. Some of the casing is still intact on the Khafre and the Bent Pyramid. As I mentioned earlier, this light-colored, smooth casing stone is another form of concrete or geopolymer. Now, let's take a look at the dry stack waste rock and tailing mound. Such mounds are permanent storage of the compacted or cemented waste material. Like all other large-scale masonry structures, water seepage would affect the structural integrity, which is to be avoided. Besides that, the runoff and seepage water flowing through the waste mound may get contaminated with residual chemicals, which will be released into the environment. This is another reason to prevent water from seeping into the mound. That's why the exposed exterior layer of a waste rock and tailing mound is designed to have a compacted rock buttress, which works as a reinforcement as well as a less permeable layer against water infiltration and seepage. It's similar to having a tarp over or under the waste mound, so rainwater wouldn't get contaminated, which could negatively affect the groundwater quality. Tarp is actually an effective way to protect the groundwater from getting contaminated from the mine waste, though it's unsightly and temporary. The pyramids were covered with fine casing stones, which was a long-lasting and elegant solution. Another thing, the pyramids of Khafre and Menkaure both have granite casing at the lower bodies. Granite is a stronger stone and an impermeable layer to protect the pyramid blocks from the elements. Even though we don't have the technology to cast granite today, the unfinished casing stone at the Menkaure show characteristics of casting, such as these knobs and bulging rounded shapes. Considering how ingenious these ancient pyramid builders were, it's possible that they obtained the technology to cast or melt granite as well. 6. Location. Today's most cutting-edge mine companies have started to evaluate and plan the total life cycle of mining and tailing management. It's more cost-efficient to have the mine waste treated and stored on-site. Limited footprints, less contamination, and fewer disturbance to the surrounding environment are the end results of better planning. If the Giza shafts were indeed a part of an ancient mining system, then it's conceivable that the waste storage was placed on-site to eliminate further impact to the environment. The Step Pyramid also have extensive underground passageways and multiple shafts. The 3D model of the underground system of the Step Pyramid is very much like an underground mining design, isn't it? Like the Osiris shaft on the Giza Plateau, there are Persian shafts right by the Pyramid of Unas in Saqqara. At Abusir, multiple underground shaft tombs are present. Ground-penetrating radar at Dashur also indicates the existence of underground archaeological remains. Perhaps all these pyramids were related to mine operations. Okay, now I have shown you 6 similarities between the pyramids and the dry stack waste rock and tailing mound. we can see that the shapes and sizes of the two are very similar. They're mostly solid structures with no foundations. They both have less permeable and buttress-like exterior layers. Plus, they're usually located near complex underground systems. Seriously, it's not easy to find another type of structure that shares these uncanny comparable features with these pyramids. If you can think of something else, please let me know. I'm open to all thoughtful viewpoints on this subject. Pyramids being waste storage sites is a provocative theory. Considering today, the cemented tailing mound is still at a conceptual stage. This means the ancients who actually built many large pyramids were way ahead of us. They were not only more technologically sophisticated, but also environmentally conscious. This lost advanced civilization which built the pyramids could be very different from us, physically, mentally, and technologically. But I think it's universal to first consider the practicality and cost efficiency of building something so tremendous as a pyramid before investing the resources and time. Whether the ancients used sound waves, frequencies, anti-gravity power, or electricity, the end goal of such projects should be able to justify the overall required effort put into it. What do you think? By the way, this is not my entire argument. There is more to be discussed, such as what was mined on the Giza Plateau, which I will save for a future video. If you have any insights, please leave me a comment. If you like my video, please give me a thumbs up and subscribe. Don't forget to hit the bell button so you'll be notified when I upload new videos. If you want to support me, my Patreon link is below. I have a wide range of topics that I want to share with you. This is Curious Being. I'm Tina. Thanks for watching and see you next time.